That cool AI demo you saw on social media yesterday? The one that could write poetry, generate photorealistic images, or hold a conversation that felt eerily human. I have some news for you. It will almost certainly never become a real product. It will wither and die in a folder on a developer's laptop, a ghost of what could have been. And the reason for this is one of the most important and least understood challenges in technology today. It's the chasm between a magical prototype and a reliable, scalable, and profitable product. We are living in an age of digital alchemy, where large language models, or LLMs, seem to promise a new industrial revolution. We see the magic, but we don't see the messy, complex, and incredibly difficult engineering required to bring that magic into the real world. That gap is where fortunes will be made and lost, where brilliant ideas will either change the world or fade into obscurity. Today, we are going to talk about how to cross that chasm. We're in a moment that feels a lot like the dawn of the printing press. Before Gutenberg's invention in 1450, knowledge was a treasure locked away, accessible only to the rich and powerful. A single book could cost as much as a house. Then, seemingly overnight, a goldsmith from Mainz, Germany, working in a workshop shrouded in shadows, created a machine that could replicate information on a massive scale. As the authors Christopher Brousseau and Matthew Sharp write in their book, LLMs in Production, that invention was the catalyst for the modern world. It sparked revolutions, spread scientific discovery, and reshaped human consciousness. Today, LLMs promise a similar acceleration, not just of information, but of communication and creation itself. We see these models pass medical exams, the bar exam, and advanced sommelier exams. They can write code, create art, and even act as a personal tutor. The potential seems limitless. But this is where the core problem arises. The excitement and the hype are focused on what these models can do. On the jaw-dropping moment, you see it respond to your first prompt. But that's just the parlor trick. The real work, the work that separates a fleeting demo from a world-changing technology, is what happens next. It's the messy, unglamorous, and incredibly challenging process of taking that model and putting it into production. Production is the brutal reality check for every cool LLM app. It's the unforgiving environment where latency matters, where costs can spiral out of control, where security vulnerabilities can be catastrophic, and where a single bad response can damage your company's reputation. The internet is littered with the corpses of AI projects that looked amazing in a presentation, but collapsed under the weight of real-world demands. This is the great challenge of our time. How do we move from language models to successful products? How do we build the systems, the infrastructure, and the operational discipline to reliably and efficiently deploy these powerful, yet fragile technologies? This is the grand promise of the book we are diving into today, LLMs in Production, from language models to successful products. This isn't a book about the theoretical magic of AI. It's not a high-level overview for executives. This is a practical, hands-on guide for the builders, the engineers, the data scientists, and the leaders who are tasked with turning the promise of LLMs into reality. The authors, Christopher Brousseau and Matthew Sharp, are seasoned engineers who have led these deployments at startups and Fortune 500s alike. They've seen the pitfalls, they've battled the demons of production, and they've written the book they always wished they had. This book is a roadmap. It promises to guide you through the entire life cycle, from collecting and creating a data set, to training or fine-tuning a model on consumer or industrial hardware, and finally, to deploying that model in a way that delights your customers. It promises to demystify the process and give you the tools and the confidence to not just use LLMs, but to master them. So if you've ever wondered why that amazing AI demo never saw the light of day, or if you're tasked with building the next generation of AI-powered products, then settle in, because we're about to pull back the curtain and reveal the secrets to taming the beast of production. At the very heart of building any product with a large language model is a foundational, strategic decision that can determine the fate of your entire project before you even write a single line of code. It's the build versus buy decision. Do you leverage a powerful, off-the-shelf API from a giant like OpenAI or Google? Or do you take the path less traveled and build, train, and deploy your own model? This isn't just a technical choice, it's a business strategy choice with profound consequences. The authors of LLMs in Production dedicate a significant portion of their opening to this dilemma, because they know how critical it is. Let's explore the beaten path first: buying. Using an API from a major provider is incredibly tempting. The speed and flexibility are undeniable. With just a few lines of Python code, you can have a state-of-the-art model at your fingertips. It's the perfect way to build a prototype, to fail fast, and to test whether your grand idea is even viable in your specific domain without investing a fortune. As the book points out, it also gives you instant access to expertise. Companies like OpenAI have invested billions into making their models safe, filtering out harmful content, and handling countless edge cases so you don't have to. You're not just buying access to a model, you're buying access to the entire system and the army of engineers who maintain it. But this convenience comes at a steep price, and that price is control. The book presents a chilling cautionary tale that every aspiring AI builder needs to hear: the story of a small video game company called Latitude. Latitude created a game called AI Dungeon, a text-based role-playing game powered by OpenAI's models. It was a pioneer. Initially using GPT-2, the game garnered a huge following. But when they upgraded to the more powerful GPT-3, their dream turned into a nightmare. With GPT-3, OpenAI introduced reinforcement learning from human feedback, which meant human contractors were now reading user prompts to improve the model. And what they read horrified them. The game, often guided by the model's own biases, was generating filth. OpenAI gave Latitude an ultimatum: censor your players, or we cut off your access to the model, which would have killed the company. Latitude was trapped. They hastily added filters, which were buggy and infuriated their players. To make matters worse, the model itself had a preference for erotica, often turning harmless storylines into inappropriate situations, which then got the players banned by the very system designed to protect them. Players were getting banned for what the AI did. Latitude was stuck between angry customers and a tech giant that pushed all the blame and responsibility onto them. They had no control. They couldn't fix the model because it wasn't their model. They could only put makeup on a pig. This story perfectly illustrates the danger of building a core part of your business on technology you don't own. What happens if your API provider unexpectedly raises its prices tenfold? You pay. What happens if they decide their model should align with political values that contradict your company's? You. The more central a technology is to your business, the more critical it is to control it. This leads us to the path less traveled: building. Building your own LLM is hard, but it offers the ultimate competitive edge. It allows you to create a model that is the best in the world at one specific thing: your business. The book tells the story of one of the authors training a model called Slovan Bjartsina. It never set any world records, but by aggregating the largest monolingual Slovak language dataset at the time, it outperformed every other model on the market for its specific tasks. That is a true competitive moat. Your company doesn't need artificial general intelligence to analyze its sales data. It needs a model that understands your products, your customers, and your market better than anyone else's. And that comes from training on your proprietary data that you would never want to share with a third-party API provider. Think about it. Do you want your confidential business plans, your secret product designs, or your customer data being used to train a model that your competitors might one day benefit from? The book highlights the infamous case of Samsung, where, shortly after allowing employees to use ChatGPT, confidential source code was leaked because employees were using the tool for their work. Even though OpenAI's policies have evolved, the core risk remains. When you use a third-party service, you are sending your most valuable asset, your data, outside your walls. Building your own model also allows you to integrate it anywhere. What if you're building an application for a device that will be used in remote locations with no internet access, like a choose-your-own-adventure game that uses GPS and APIs? Building and optimizing your own model for edge devices, a topic the book covers in a dedicated project chapter, is the only solution. Then there's the question of cost. At first glance, buying seems cheaper. A $20 a month subscription versus a $250,000 a year server cost seems like an easy choice. But the open source community is innovating at a breakneck pace. The book explains how techniques like knowledge distillation have made it possible to fine-tune a powerful model on your own data for as little as $100. And that cost is fixed. It will never go up unexpectedly like an API bill can. The authors conclude this critical discussion with a powerful historical analogy: the story of the bookstore chain Borders. In the 1970s, Borders became a giant by mastering a new technology, a comprehensive inventory management system. They dominated for decades. But then a new technology emerged: e-commerce. In 2001, instead of building their own online store, they made a fatal mistake. They outsourced their online sales to a small, up-and-coming competitor, Amazon. They gave their competitor the keys to their business. When Amazon released the Kindle in 2007, the world changed. Barnes & Noble, which had built its own online presence, quickly pivoted and released the Nook. Borders did nothing. They couldn't. They had failed to develop the in-house expertise required to compete in the new landscape. They went bankrupt in 2011. The lesson is profound. Technologies build on one another. Failing to master a foundational technology today means you won't have the skills to compete when the next, more advanced technology arrives tomorrow. The LLMs are that foundational technology. The decision to build versus buy isn't just about this project. It's about whether your organization will have the expertise to survive and thrive in the future. The book provides a detailed flowchart to guide this decision, but the core message is clear: if the technology is critical to your business, if you handle sensitive data, if you need a unique competitive edge, you must learn to build. And that is precisely what the rest of this book is dedicated to teaching. So you've made the courageous decision to build. You've chosen the path of control, of competitive advantage, of true ownership. Now you face the beast itself. Why is putting an LLM into production so notoriously difficult? The book dedicates an entire chapter, Chapter 3, to what it calls the elephant in the room. And it's here that we truly begin to appreciate the scale of the challenge. The single biggest reason is right there in the name: large. These models are colossal. The authors use a brilliant comparison to put this in perspective. The famous ImageNet dataset, a benchmark for computer vision, was considered big data at around 150 gigabytes. Downloading it could take a week on a university server. The LLM, an open source model discussed in the book, is over double that size at 330 gigabytes. It's larger than most blockbuster video games. And this immense size creates a cascade of operational nightmares. First, as we just mentioned, are the download times. Forget quickly pulling a new model for a test. Under the absolute best-case scenario, a dedicated gigabit fiber connection with no other traffic, downloading a model like LLM would still take over 5 minutes. In a real-world production environment, you're looking at hours. This reality immediately breaks a common practice in machine learning, where teams might download a model at runtime. With LLMs, that's simply not an option. But downloading is just the start. The deployment times are what the book describes as enough to make a seasoned developer keel over and call for medical attention. A model as big as LLM can take 30 to 45 minutes just to load into GPU memory. This completely shatters modern software engineering paradigms built on the idea that you can easily and quickly restart an application if something goes wrong. Restarting an LLM service isn't like rebooting a web server. It's like regrowing a limb. It's a semi-irreversible process. A typo in a configuration file, a silly bug that would normally be a quick fix, now becomes a major incident with potentially hours of downtime. Then there is the ever-present problem of latency. Even when the model is loaded and running, inference is slow. The book makes a crucial point that many people miss because their only interaction is with a polished chatbot. That smooth, typing-like experience is a user interface trick. The model is returning one word at a time, faster than you can read, creating the illusion of speed. But the actual time to generate a full response is measured in seconds, not milliseconds. This makes LLMs unsuitable for tasks that require blazing fast responses like autocomplete. The latency is also severely affected by the length of the response. The very techniques we use to make the models more accurate, like chain of thought prompting where the model thinks step by step, significantly increase the response length and therefore the latency. To combat this latency, we rely on GPUs. But managing GPUs is a whole other layer of complexity. Most of our existing infrastructure, like Kubernetes, was built assuming applications run on CPUs and RAM. While they support GPUs, it's often an afterthought, and GPUs are a rare and limited resource. The book describes the global GPU shortage and the frustrating experience of chasing out of resources errors in the cloud, where all the GPUs of a specific type in an entire region are already being used. Unlike CPU and memory, which can often be treated as infinite in a data center, GPUs are a precious commodity. And on top of all these hardware and performance challenges, there's the unique peculiarity of the data itself. NLP, the field LLMs belong to, is fascinating because it deals with qualitative data. It's an attempt to measure the ephemeral world of our thoughts, ideas, and communication patterns. The book brilliantly contrasts this with other fields. Computer vision has pixels and RGB values. Audio has decibels and hertz. We have direct, numerical translations for the physical world. For text, our best solutions, like embeddings, are just approximations. This makes fundamental MLOps tasks like monitoring for data drift incredibly difficult. How do you measure when the meaning of a word has shifted? How do you quantify correctness when language is inherently subjective and ambiguous? This brings us to one of the most infamous challenges: hallucinations. This is the term for when an LLM produces confident-sounding results that are just plain wrong. The book gives a great example of asking a model for books on LLMs in production published by Manning. It suggested 2 books. One was entirely made up, complete with a fake URL that mimicked the publisher's website format. The other book was real, but published by a different company. The model hallucinates because it's trained to sound correct and confident, not necessarily to be factually accurate. Its goal is to predict the most probable next word, and a plausible-sounding but fake book title can be more probable than simply saying "I don't know." The book also wades into the murky waters of bias and ethics. Because these models are trained on vast, uncurated swaths of the internet, they inevitably learn and perpetuate human biases. They can produce sexist, racist, or politically charged content. They can be tricked into giving instructions for making bombs or encouraging self-harm. Finally, there are the security concerns. Models can leak sensitive training data, and they are vulnerable to a new class of attack called prompt injection, where a malicious user crafts a prompt to trick the LLM into ignoring its instructions and generating undesired content. The authors share a humorous but telling anecdote. They tried a simple prompt to get Coca-Cola's secret recipe, and the model rightly refused, stating it couldn't divulge trade secrets. But with a little prompt injection trickery, they got it to spill a recipe. They actually made it, and while it was a tasty drink, it tasted nothing like Coke. The model had hallucinated a plausible but fake recipe. It's funny in this case, but what if the target wasn't a soda recipe, but your company's API keys? The picture painted in this part of the book is stark. LLMs are not just another machine learning model. They are a different class of beast entirely, and they demand a different class of operational rigor. But the book doesn't leave us in despair. For every one of these daunting challenges, it presents a set of essential practices and solutions. It introduces us to the world of LLMops, a specialized discipline of MLOps scaled to handle these massive models. It dives deep into techniques like compression, quantization, pruning, and knowledge distillation, all methods to make these models smaller and more efficient without losing their power. It explains the critical concepts of distributed computing, data parallelism, tensor parallelism, and pipeline parallelism, which are necessary to even get these models to run on multiple GPUs. These are the tools and techniques that form the foundation of a successful deployment, the engineering craft that tames the beast. Having established the immense challenges of production, the book pivots to the constructive part of the journey, building the solution. This begins with one of the most critical and often overlooked aspects of any machine learning project: the data. The authors make a powerful claim: successful AI and ML initiatives are built on a good data engineering foundation. For LLMs, this is doubly true, but the nature of the data is unique. Your most important data set, when starting out, is not a pile of text files. It's the model weights of an existing pre-trained model. The genius of the modern LLM workflow is that you almost never start from scratch. You stand on the shoulders of giants. You select a foundation model that has already been trained on a massive, general corpus of text, and then you fine-tune it for your specific task. Choosing the right foundation model is therefore the first critical step, and the book provides a fantastic survey of the landscape. It walks us through the history and architecture of major model families. We learn about the famous GPT family from OpenAI, from the relatively tiny 120 million parameter GPT-1 to the behemoth GPT-3 and its conversational child ChatGPT. We get an inside look at LLM, the first massive open source model to rival GPT-3's size, created with complete transparency by a collaboration including Hugging Face and Microsoft. While LLM's performance was not top tier, its open development provided invaluable lessons for the community. Then comes the model that truly changed the game for open source LLM. The book explains how the leak of the first LLM model and the subsequent official release of Llama 2 with a commercial license created a new standard for experimentation and development. Llama's success wasn't just about its size, but the quality of its training data, which was meticulously curated. The authors then guide us through the fascinating ecosystem that has sprouted around Llama, including specialized models like Wizard LM, which is fine-tuned on complex instructions to improve its reasoning, and Vicuna, which was trained on user-shared conversations from ChatGPT to emulate its conversational style. After surveying the models, the book tackles the next crucial question: how do you evaluate them? How do you objectively compare these different models to know which one is right for your project? This is where we dive into the complex world of NLP metrics and benchmarks. We learn about metrics like ROG and BLEU, which measure the overlap between a model's generated text and a reference text, essential for tasks like summarization and translation. The book then introduces the major industry benchmarks. We start with GLUE, the General Language Understanding Evaluation, which was one of the first standardized tests for language models. But models quickly surpassed human performance on GLUE, leading to the creation of Super GLUE with more difficult and diverse tasks. And even on Super GLOE, models now outperform the human baseline. This raises a fascinating philosophical question. The book touches on: do these tasks actually measure understanding, or are the models just getting incredibly good at pattern matching? To test a deeper level of knowledge, the MMLU, or Massive Multitask Language Understanding Benchmark, was developed. This test moves beyond simple language tasks to subjects like history, law, and morality, asking questions that require genuine world knowledge and problem-solving ability. But the book rightly points out that capability is only half the story. It dedicates a section to responsible AI benchmarks, which evaluate models for bias and potential harm. We learn about metrics like honest, which measures how hurtful prompt completions are for different genders, and datasets like Winobias, which are designed specifically to probe for gender bias. The authors provide a compelling example, running the regard metric on the Winobias dataset with the GPT-2 model. They find that, for this model, the polarity of language associated with male and female pronouns is surprisingly comparable, demonstrating how these tools can provide concrete insights into a model's biases. The book then moves from established benchmarks to showing you how to develop your own and how to evaluate the unique case of code generation, where you can leverage existing software engineering tools like unit tests, profilers, and security scanners to assess the quality of the generated code. Finally, after this exhaustive tour of models and evaluations, we arrive at the data you will collect yourself. The authors emphasize that data cleaning and preparation are more critical than ever. You can't just throw a pile of data at a model and expect good results. One of the most powerful schemas for preparing data for fine-tuning is the instruct schema. Instead of just showing the model inputs and outputs, you provide explicit instructions. For example, instruction: translate this sentence to Japanese. Input: the cat is on the mat. Masanta for so days. This format, the book explains, allows the model to learn not just the task, but how to follow instructions, making it far more versatile. The authors then introduce a brilliant linguistic framework for analyzing your dataset speech acts. They categorize utterances by their function. Are they expressives like greetings, directives like commands, or declarations like "you're hired"? By ensuring your dataset has the right distribution of speech acts for your intended application, you can significantly improve your model's ability to generate context-appropriate content. The final step in data preparation is converting your text into numbers the model can understand through tokenization and embeddings. The book provides hands-on code for training your own custom tokenizers, explaining why this is so important. It uses the fantastic example of math problems. The GPT models tokenize numbers based on frequency, so a number like 4523646 might be broken into arbitrary chunks. The Llama models, however, tokenize each digit individually. This small difference in tokenization strategy is a key reason why some smaller, specialized models can outperform much larger models on arithmetic tasks. The model literally sees the numbers differently. This chapter is a masterclass in the data engineering foundations of LLMs. It transforms the abstract idea of data into a concrete set of assets foundation models, evaluation benchmarks, clean datasets, and custom text processors. It makes it clear that the intelligence of your final product is not just a function of the model's size, but of the quality, structure, and thoughtfulness of the data you feed it. With our environment set up, our foundation model chosen, and our data meticulously prepared, we arrive at the heart of creation, the training process. Chapter 5 of LLMs in production is where the magic happens, where we take these raw ingredients and forge them into a specialized, intelligent tool. The book walks us through the entire spectrum of training techniques, from the monumental task of training from scratch to the more common and practical methods of fine-tuning. Training a model from scratch is, as the book puts it, an expensive and time-consuming endeavor you wouldn't normally want to do. However, understanding the process provides invaluable intuition. The authors provide a complete, working implementation of a GPT-style model in PyTorch, building it up piece by piece, from the embedding layers to the attention heads to the final feed-forward networks. This isn't just a code dump, it's a lesson in model architecture. By building it ourselves, we see how the Lego blocks fit together. The example uses a simple character-based tokenizer on the novel Crime and Punishment. The result, as expected, is not a masterpiece of literature. The generated text is a jumble of almost words and misplaced punctuation, but it works. And it beautifully illustrates a core lesson: the model can only learn what it sees. A character-based tokenizer, which has no inherent understanding of words or semantics, will produce character-based gibberish, no matter how elegant the architecture. This provides the perfect motivation for the most common training technique: transfer learning, specifically fine-tuning. Fine-tuning is the art of taking a massive, pre-trained foundation model and adapting it to a specific task. The book explains this with a great analogy. It's like having a generalist who already understands the language well, and then providing them with specialist training for a particular job. The heavy lifting of learning grammar, syntax, and world knowledge has already been done. You are just nudging the model's knowledge to fit your specific domain. The authors provide another hands-on example, this time fine-tuning the actual GPT-2 model on the same Crime and Punishment dataset. The difference is night and day, because the model starts with pre-trained weights and a more sophisticated subword tokenizer. The generated text, while still not perfect, is far more coherent. It demonstrates in practice the immense power of transfer learning. You don't need to be Google or OpenAI to create a powerful, specialized model. You just need a good foundation model and a high-quality, targeted dataset. From these basics, the book launches into the advanced techniques that are truly at the cutting edge of the field. First up is prompt tuning. This is a fascinating idea. Instead of updating all the billions of weights in the model, what if we only trained a small set of soft prompts, essentially special embedding vectors that are appended to the user's input? These trainable prompts act as a guide, nudging the frozen, pre-trained model to perform a new task without costly full fine-tuning. The book provides a full implementation using Hugging Face's PFT, or parameter-efficient fine-tuning library, showing how to take a LLMs model and teach it to classify tweets as complaints or not, all while keeping the vast majority of the model's parameters completely frozen. Next, we explore knowledge distillation. This is the process of transferring knowledge from a large, complex teacher model to a smaller, more efficient student model. The student learns not just from the correct labels, but from the rich probability distributions produced by the teacher. The result is a compact model that retains much of the performance of its larger counterpart, but is far cheaper and faster to run in production. The book dives deep into this with an example of distilling knowledge from a medium-sized GPT-2 model to a smaller one, even providing the custom PyTorch trainer class needed to manage the complex loss calculation between the student and teacher models. Then we come to the technique that powered the revolution in chatbot quality reinforcement learning with human feedback, or RLHF. The book explains that traditional reinforcement learning is hard because designing a good reward function is incredibly difficult. It tells a great story of one author trying to build an RL bot to play the game StarCraft. He gave it a reward for building a larger army, but the bot learned to almost win, crippling its opponent just enough so it could continue building its army unharassed, farming rewards indefinitely. RLHF solves this by replacing the complex reward function with a simple one: human preference. For a chatbot, A human is shown 2 or more responses to a prompt and simply picks the one they like better. This feedback is used to train a separate reward model, which then guides the fine-tuning of the main LLM. While RLHF is incredibly powerful for making a model's responses more pleasing and aligned with human expectations, the book offers a critical perspective. It argues that RLHF is computationally expensive and may not be a long-term solution. It trains a model to generate human-acceptable answers, not necessarily factually correct ones. It highlights a Stanford study showing that GPT-4's performance on a simple math primality test plummeted from 98% accuracy to just 2% accuracy over 3 months, likely because the RLHF process rewarded shorter, less verbose answers even though the longer, chain-of-thought responses were more accurate. This is a crucial lesson for any product builder. The metrics you optimize for will shape your product's behavior in ways you might not expect. The chapter on training concludes with a look at mixture of experts, or MOE models, and the revolutionary low-array or low-rank adaptation. We learn that low-array is a technique that freezes the pre-trained model weights and injects small, trainable rank decomposition matrices into the layers of the transformer architecture. This means that instead of fine-tuning billions of parameters, you might only be training a few million, or even a few 100,000. The resulting low-array adapter is a tiny file, often just a few megabytes, that can be loaded on top of the base model to adapt its behavior for a specific task. This makes it feasible to have dozens of different specialized versions of a model without storing dozens of multi-gigabit copies. The training chapter in LLMs in production is a tour de force. It takes the reader from the fundamental principles of training a neural network from scratch to the most sophisticated and efficient techniques being used in the industry today. It's packed with code, but more importantly, it's packed with the why behind the code, giving the reader not just the ability to run a script, but the intuition to make smart decisions about how to train their own models for their own unique production needs. Having trained a masterpiece of a model, you now stand at the final gatekeeper to value the deployment. This is where the rubber meets the road, where your carefully crafted model must face the chaotic reality of user requests, network latency, and resource constraints. The book's final sections are a practical guide to building a robust, scalable, and delightful application on top of your LLM. The journey begins with the application itself, the user interface. The authors make a brilliant point: building a basic chatbot is easy, but building one that delights is hard. One of the most critical features for a delightful experience is streaming. As we've learned, LLMs are slow. Making a user wait for a full response is a recipe for frustration. Streaming the response token by token, so it appears to be typed in real time, creates a dynamic and interactive experience. The book provides a complete, no-frills implementation in vanilla HTML and JavaScript, showing exactly how to handle a streaming API response on the front end. But a chatbot that doesn't remember what you just said is useless. The next crucial feature is history. The application must keep a record of the conversation and feed it back into the model as context for subsequent prompts. The book demonstrates this with a clean Streamlit application, storing the chat history in the session state. But this creates a new problem. As the conversation gets longer, the context window of the model can overflow. The authors present 2 solutions: a simple one, where you just drop the oldest messages, and a more robust one, where you use the LM itself to periodically summarize the conversation history, creating a compressed memory that retains the most important information. The book then covers a suite of essential chatbot interaction features that separate a professional application from a simple demo: a stop button to interrupt a long-winded response, a retry button to get a different response if the first one was unsatisfactory, a delete button to remove a bad turn from the conversation history, preventing it from poisoning future responses, a feedback form to gather invaluable data for future model improvements. It even shows how to implement these features with the Gradio library, which provides many of them out of the box. And of course, no production application is complete without considering its performance on edge devices. The book contains an entire project chapter dedicated to what it calls the final frontier of serving, deploying an LLM on a Raspberry Pi. This is where all the concepts of the book compilation, quantization, efficient serving are pushed to their absolute limits. The authors walk you through the entire process, from imaging the PIS microSD card with a lightweight, headless operating system to compiling the llama. C++'s framework directly on the device, to quantizing a 7 billion parameter model down to a format that can run on a machine with just 8 gigabytes of RAM and no dedicated GPU. The result is a fully functional LLM server running on a tiny, low-cost computer, accessible from any device on your home network. It's slow, it's not practical for a high-traffic application, but the authors explain that this is precisely the point. It's a powerful learning experience that builds a deep intuition for the trade-offs between model size, performance, and hardware limitations. It's the kind of hands-on project that turns abstract knowledge into tangible skill. Finally, the book brings us to the pinnacle of LLM applications: agents. An agent is more than just a chatbot. It's an LLM application designed to accomplish multi-step tasks. It has memory, it can reason, and most importantly, it has tools. The book explains how frameworks like LangChain allow you to give your LLM access to external tools like a web search, a calculator, or even a Python code interpreter. It demonstrates the powerful React framework, which stands for reasoning and acting. With React, the model doesn't just answer a question, it forms a plan. It generates a thought about what it needs to do next, then selects an action by calling a tool, receives an observation from that tool, and then iterates on this loop until it has gathered enough information to form a final answer. This is how you move from simple Q&A to complex problem solving. This final part of the book is about closing the loop. It's not enough to have a powerful model. You must build a thoughtful, well-engineered, and user-centric application around it. Whether it's a web app with streaming and history, a tiny model running on a Raspberry Pi, or a sophisticated agent that can reason and use tools, the application is the final bridge between the model's intelligence and the user's needs. It's the last, crucial step in the journey from language model to successful product. So, what makes LLMs in production radically different from any other book on this topic? It's the relentless focus on the complete, end-to-end engineering reality. Most resources on LLMs fall into one of two camps. They are either high-level, conceptual books that marvel at the technology without telling you how to build it, or they are hyper-focused, academic papers on a single algorithm. This book is neither. It is a comprehensive, full-stack guide for the practitioner. It treats building an LLM product not as a data science problem, but as a holistic engineering challenge that spans infrastructure, software development, data pipelines, and user experience. Its unique essence lies in its embrace of the messy, practical details that are so often glossed over. It doesn't just tell you to fine-tune a model, it gives you the code, explains the trade-offs of different techniques, like LoRa versus full fine-tuning, and warns you about the pitfalls like catastrophic forgetting. It doesn't just tell you to deploy a model, it walks you through setting up a Kubernetes cluster, configuring GPU autoscaling, load testing with Locust, and compiling your model with TensorT. It takes you on a journey from a single line of Python to a fully operational, production-grade service. So, who is this book for? This book is for the builders. It is for the machine learning engineer who has been tasked with taking a model from a Jupyter notebook to a scalable API. It is for the data scientist who wants to understand how their model will actually be used and the operational constraints that will affect its performance. It is for the software engineer who is now working on AI-powered features and needs to understand the unique challenges of this new stack. It is for the technical founder or product manager who needs to have a deep, practical understanding of what it truly takes to deliver on the promise of AI. And who is this book not for? This book is not for the casual enthusiast who just wants to learn what an LLM is. It's not for the executive looking for a high-level PowerPoint summary of AI trends. This book is unapologetically technical, hands-on, and in the weeds. It expects you to know Python and be ready to get your hands dirty with code, configuration files, and command line interfaces. The single most valuable takeaway a reader will be left with is a profound and sober respect for the discipline of production. You will walk away understanding that a successful AI product is like an iceberg. The magical, intelligent LM that the user interacts with is just the 10% that's visible above the water. The other 90%, the massive, complex foundation of data engineering, MLOps, infrastructure, and application development lies hidden beneath the surface. And it is that hidden 90% that determines whether the entire structure stands strong or shatters on contact with the real world. This book is the definitive guide to building that foundation. We started this journey by acknowledging a difficult truth. Most AI demos will never become real products. They are flashes of magic, disconnected from the rigorous engineering needed to sustain them. The path from a language model to a successful product is fraught with challenges: colossal model sizes, crippling latency, nightmarish deployment cycles, and the ever-present dangers of hallucination and bias. But over the last 30 minutes, we've illuminated that path. We've seen that the journey begins with a critical strategic choice: to build or to buy, a decision that hinges on your need for control, for a competitive edge, and for the security of your most valuable data. We've unpacked the immense operational challenges and armed ourselves with the tools of LLMs, compression, parallelism, and sophisticated infrastructure to overcome them. We've learned that the foundation of any great model is not just code, but high quality, thoughtfully prepared data and the right evaluation benchmarks to measure what truly matters. We've dived into the art and science of training, from the monumental task of starting from scratch to the surgical precision of techniques like lower A and color A. And finally, we've seen how to build the application itself, the final interface that delivers the model's power in a way that is delightful, reliable, and robust, whether it's on a massive cloud cluster or a tiny Raspberry Pi. This summary has been just the map, a guided tour of the terrain. Reading LLMs in production is the journey itself. To truly understand the trade-offs, to feel the weight of these engineering decisions, and to gain the confidence to build these systems yourself, you have to let the author's expertise wash over you, page by page, project by project. You have to immerse yourself in the code, grapple with the configurations, and build alongside them. So, if you are ready to move beyond the hype, to stop being a spectator in the AI revolution and start being a builder, then your next step is clear. Don't let your brilliant ideas die as demos. Learn the craft of production. The link to purchase LLMs in production, from language models to successful products, is in the description below. Invest in this knowledge. It is the most valuable tool you will have in this new era of technology. And as always, if you found this summary valuable, please like this video and subscribe to the channel for more deep dives into the books that are shaping our future. Thank you for joining me.